So first off, a hurricane is a really intense tropical low pressure. There's a few different things about a hurricane and a tornado. One is the size, two is where they form, and three is how they form. So tornadoes are rapidly rotating columns of air that form usually over land, and they only are a few miles in width. Hurricanes, on the other hand, are really intense tropical low pressures. They form over warm tropical oceans, and they can span tens, hundreds, and thousands of miles in width. So they're much larger as well. Now, with that said, the National Hurricane Center, so we actually have a branch of the National Weather Service entirely devoted just to hurricane tracking and forecasting, issues a series of products that I'm going to walk you through in this investigation. The first big product that they issue is this map that you're looking at right here. And this is actually one of the maps that I took straight from this exercise, from this investigation. And let me show you what's going on here. So first off, this is a beautiful map of much of the tropical Atlantic Ocean, at least the northern tropical Atlantic Ocean. And you do have a little bit of areas for reference. So over here is Puerto Rico, Haiti and the Dominican Republic, Cuba, Florida, and so on. And this particular storm that we're looking at is Tropical Storm Irma. And to determine what storm is being shown on the map, you can always look over here in this white pane beneath the map, and in the upper left, they actually have the name of the storm. Beneath that, they have the timing that this map was issued, who issued it. Then here in the middle pane, they have the current information about the storm, so where the storm is located in terms of longitude and latitude. So right now the storm is, and it's actually also this black dot with the orange circle around it, so right here. And this storm is currently located at 16.5 north and 32.9 west, so right over here. So 16.5 north, that's a little above the 15 longitude or latitude line, and 32.9 west is a bit west of the 30 latitude or longitude line. Beneath that is the maximum sustained winds. This is actually, let me get my pointer out actually. So right here are the maximum sustained winds, and they always put it in miles per hour, and this tells us how intense the storm is. So usually when we look at hurricane intensity, we are typically looking at the maximum sustained winds. And then finally, the movement of the storm. So this tells us all the current information we need to know. Now let's actually talk about what we actually see here. So the plot, or this point that's plotted right here, is the current location of the storm. Extending out from that point is a black line with these dots on it, and what this is actually showing is the forecasted location and intensity of the storm. And the location is determined by where the black dot is, and the intensity is determined by, or is shown by the letter inside the black dot. So right over here you see these H's, these actually represent hurricane. And then these M's over here represent major hurricane. The last thing I want to show you though is also extending out from this dot is this what looks like a shaded area cone. This is what's called the cone of uncertainty. So hurricane forecasts aren't perfect. And as such, the center of the hurricane can veer a little bit off of what the predicted path is. And even a small veering in the location can have major implications. So as a result, in addition to showing the current predicted path, they also show this cone. And this cone basically says the hurricane can land anywhere in this cone over time. The center of the hurricane can land in this cone anywhere over time. One of the things you'll notice is that, so this is the current location. If you notice, Close to the current location, the cone is relatively narrow. However, the further out you get, the wider the cone gets. And that makes sense because forecasts are best when they're very short term. However, once you get little errors in the short-term forecast, those errors can then amplify and create bigger errors in the long-term forecast. So, TLDR, basically, hurricane forecasts are the best very short-term, but the further out you go, the more uncertainty there is.